have you ever stopped to think if a string of numbers and letters could actually, draw a picture? Well, today we're going to crack the code that connects the world of algebraic equations to the visual world of geometry. And trust me, it's a connection that is way cooler than you might think.
So, this is the big question, right? This is the mystery we're going to solve together. Can an equation, just a simple line of symbols, actually hold the blueprint for a perfect shape? Let's find out.
Okay, so to crack this code, we have to start small. Think of it like learning a new language. You got to start with a single letter, a single idea. In our case, that's a single variable.
Now you're going to hear this word linear a lot. All it really means is that our variable, x, isn't doing any fancy tricks. There's no x squared or x cubed. It's just plain old x. And in this super simple setup, our whole mission is to find the one and only value for x that solves the puzzle.
So let's look at a really simple puzzle. X minus 3 equals 0. What single number can you put in for x to make that statement true? It has to be 3, right? It's totally locked in. No other number in the entire universe will work. In this equation, x has one single unchangeable identity.
And that's the key takeaway here. With one variable, you get one unique solution. And this isn't just some random number. It represents a single fixed location. You can literally think of it as one specific dot on a number line. That's it. Story over.
But, things get a whole lot more interesting when we break out of that one-dimensional world. Let's see what happens when we introduce a second character into our story.
So what happens when we throw a y into the mix? Well, we change the entire game. The equation is no longer about finding one fixed value for x. Instead, it becomes about describing a relationship, like a partnership, between x and y.
And this is where it gets kind of mind-blowing. That one simple change, just adding one more letter, doesn't just give us a couple more answers. Nope, it unlocks an infinite number of them. Remember that single, lonely solution we had before? Yeah, forget about that. Now, instead of one answer, we have a bottomless ocean of possibilities, an absolutely endless list of pairs of x and y that can work together to solve the equation. Let's look at a real example. X plus y equals 4. As you can see in this table, the combinations just keep coming. If x is 2, then y has to be 2. If x is 1, y has to be 3. We could even get crazy and say if x is 100, then y has to be negative 96. We could seriously sit here and fill this table out forever. At first, these pairs just look like a random jumble of numbers, right? There doesn't seem to be any connection. But what if there's a hidden pattern? What would happen if we took these solutions and actually plotted them as coordinates on a graph? This brings us to the big reveal, the moment we've been waiting for. It's time to take all those infinite solutions and finally see the picture they've been trying to draw for us this whole time.
So how do we actually turn this number code into a picture? It's actually a pretty simple process. First, you take a solution pair, something like 2, 2. Then you just treat it as an x, y coordinate. Third, you plot that point on a 2D graph. Then you do that for a few more of our solutions. And finally, the magic step. You connect them and see what pattern pops out.
And boom, there it is. All of a sudden, the chaos turns into perfect order. All those infinite solutions don't form a random cloud of dots. They all line up to create a perfect straight line. This is why we call them linear equations. The algebra isn't just solving a problem. It's literally drawing a picture.
Now this, right here, is the most important idea to get. That line isn't just a random shape. It is the equation, just in a visual form. Every single point on that infinitely long line is a valid solution, and every possible solution you could ever find has its own unique spot somewhere on that line. They're two sides of the same coin. So, now that we've cracked the code, we can actually start to speak this language of lines. We can use simple equations to describe specific pictures with absolute precision. Let's check out a couple of special cases. An equation like x equals 3 is a really strict rule. It says x must always be 3, no matter what y is doing. And when we plot that rule, what do we get? A perfectly vertical line. And it's the same for y equals -1. That gives us a perfectly horizontal line, because y is always locked in at -1. And get this, it gets even cooler. The actual axes of the graph, the ones we use to plot everything, they follow these rules too. The y-axis is just a line where x is always 0, so its equation is simply x equals 0.
And the x-axis? Well, that's just a line where y is always 0, so its equation is y equals 0. See? It all fits together perfectly.
So we figured it out. The simple code of a linear equation draws a perfectly straight line, which, of course, leaves us with one final, really fascinating question. If that's the secret code for a line, what kind of algebraic code would you need to write to draw a perfect circle?